So I'll be talking about how to go about the assignment, or basically how I went about doing the assignment. So the first thing, import your image, your extracted image. So this my image has been georeferenced, is a geotiff image. Then you also import all your data, or if you just have one data. Me, I splitted mine into three. That's the spot height, the tree, the and the building. You also have to digitize all buildings. That's what I've done here. Let me show it properly. So I digitize all the buildings and also the boundary as seen here. So for the building part, for the detailed building, you are going to add an attribute field of height to it, so that each building, based on your field survey with your total station, the height you got, you are going to write the respective height in this height field. So just like I've written for this part. So now the first step will be converting your CSV file into shape files. So the first thing you do is right click on this, then go to display XY data. Then okay, let me show you how my CSV file is saved. So for instance, here I have the XYZ, where the X is the one that starts with 544, then Y starts with 720, then Z is my height and feature. So arrange is basically good, better to arrange it this way. Let your X be the one with the 544, let your Y be the one with 720, then state Z as your height. Then this other last one is just an extra attribute that I added to the table. So now back to this place. So now once, okay, let me go back. I right click on this, I click on display XY data. So once I've done that, I set my X field as X. That means take this X field, X coordinate as the values of all those coordinates I've set. Take the Y2 as the values of those Y, and Z as my Z value. Then you must have set your coordinate system in your data frame. Yeah, I think everyone should know how to set coordinate system. But for those who don't know, and just click OK. For those who don't know, just come to this view here, go to data frame properties and navigate to projected coordinate system, then to UTM. After UTM, you go to WGS 1984 Northern Hemisphere, and since it's Lagos, you pick zone 31. That's this one here. So once you have set it, just apply and you click on OK. So I've set mine here. So automatically the first layer that we created is already on the field, just as seen here. Let me sorry. So as you can see, these are the point data, these are the spot height. Then you also do the same thing for other CSV file, X, Y, X. So one important thing, so once you are done, next thing for you to do is you can remove them. Just remove data. One important thing for you to know is this has not been converted to shapefile. They've only been converted to layers. So now to convert them to shapefile, you right click on it, then go to data, then export data. Then here I'll state I want to save this on this file and save it as building. Building. So then ensure the save type here is shapefile. Then click on save and click OK. Then yes. Then you come to the tree, also do the same thing. So after you have saved that, we can remove this, and now they are already shape files. You can see from my working directory here, this is building.shapefile. Then we have the build.shapefile, tree.shapefile, and spotlight.shp. So now after this, the next thing for us to do is to create our DTM, that's digital terrain model. So for the terrain model, we're just going to be using our spot height and the boundary. Now how do we create the terrain model? Come to your arc toolbox here, click on it. So under arc toolbox, then you click on 3D analyst, then data management, then you are going to see tin. Click on tin, then click on create tin, because we are first going to convert our data to a triangular irregular network. So from tin, we'll now convert it to a raster data. So here I'll be setting my output. Yeah, I'll come here, save to this place, name it as DTM 10. So save here, then set my coordinate system, then import the feature classes I want. So since it's DTM, I'm just concerned with the terrain, and terrain has to do with just my spot height based on my own data. So I pick my spot height, then I want this spot height data to be within my boundary. So that's why I pick boundary. So for here, notice the type. This place chooses mass point, and this place picks soft clip. That means it's going to clip it within that area. And this one, because being a point data is just multiple points, then you can now click on OK. It's currently creating. So this has been created automatically. So now to convert it to raster, under this same 3D analyst tool, we can close this, go to conversion. So we are converting from tin, then click tin to raster. So input that tin, the tin here we have is DTM 10. Then I can come here, select my no, I want to save it as DTM, rather save. Then set this one to natural neighbors, set this to this cell size given, cell size here, and just click on OK. So once you do that, automatically if I put up this layer, we can see that the DTM raster has been created. So now for the DEM, let me go through how we can create the DEM. To create the DEM, you can close this 3D analysis. Within that same Arc toolbox, click on this spatial analyst tools, then click on interpolation. Under interpolation, click this IDW, or double click rather. Then from here, input the features. It's also spot height we are going to use to create our DEM. So just click spot height. Here, this one takes only one field. Then select the field you want it to record with. It's going to record it with the Z field, which is our height. Then leave the remaining default. Then you can just change this to maybe 8. So depending on whatever you set for this cell size and this number of points, it takes more time, and it interpolates with closer reading. So then click OK. So automatically it creates the DEM. So let me put up these layers. So once this have been created, you have your DTM, then you have your DEM. This is your DEM and this is your DTM. And that's all for this first one.